But y'all listen, the purpose of what we're doing here today is to kind of throw together all the types of equations that we've looked at in separate sections during Saxon. Saxon might have covered this over 5 different lessons, but I want to kind of put it all together. And this is actually a presentation that I've used in college algebra or algebra 2 just to review solving linear equations. You're going to have no problem with most of these, but we're going to kind of challenge you on a couple of points as we move through this. So we're solving linear equations kind of in review of what we've learned this year so far about solving linear equations. We started off with very simple equations that we can solve by observation, right? What is the solution to this equation? X equals 5, and we know that because 5 plus 3 equals 8. Right, but what inverse operations will we use to solve this? What would we do to solve this equation? Subtract 3 from both sides, okay? And when we subtract 3 from both sides, that's going to isolate the x, and we're left with x equals 5.
And that's the answer?
And that's the solution. Now, one thing that we've not done a lot is you can always check the answer to your equation, can't you? So you can always know beyond any doubt that your answer is correct by just plugging the solution back into the equation and seeing if it results in a true statement. So if we plugged 5 in for x there, what would we get? 5 plus 3 equals 8. And Mackenzie, that's a true statement, isn't it? Okay. All right, two-step equations was what we did kind of next.
Plus 5.
You add 5 to both sides to get the x term by itself.
Divide by 2.
Divide both sides by 2. And again, this is an equation that most of you could solve by observation.
X equals 7.
9 plus 5 is 14, and 14 divided by 2 is 7. So you guys can do this really easily. What we get to, hold on just a second. What we get to with this next one, maybe you can, maybe you can't solve it by observation, because what comes up in this problem? Fractions come up, right? So when you add 8 to both sides, you get 14, and 14 divided by 3 is not really one of our favorite numbers, but it is a number, and it is the solution. Okay? How would we check this one? Plug it into our equation in the place of x. 3 times 14 over 3 minus 8 equals 6. Is that true? If it's true, then we have a good solution. If it's not true, we don't have a good solution. So I can cancel the 3's, and I'm left with 14 minus 8 equals 6, and that is indeed a true statement, so the solution is good. So even when you have equations, it's easy to plug even when you have fractional answers to your equations, it's easy to plug them into your original equation and get a solution. Okay? Let's have a look at something that's a little bit more difficult. Write this one down. 5x minus 6 equals 2x plus 9. Now, what's different about this equation is that I have a variable on both sides. And this is where it starts to get a little bit tricky. If you don't do things in the correct order, the equation can be difficult. What's the correct thing to do here when we have a variable on both sides?
I'd like terms.
You get the variable by itself first. We do not add 6 to both sides. We do not subtract 9 from both sides. We're going to either subtract 5x from both sides, or we're going to subtract 2x from both sides. Which one would you choose? Subtract 2x from both sides. That'll keep things positive. You don't have to do it that way, but when you subtract 2x from both sides, then we are reducing this to a two-step equation that we probably could solve in our heads at this point. Add 6 to both sides, right?
X equals 5.
And when you add 6 to both sides, you get 3x equals 15, which means x equals 5. All right? Now, what would we do to check our answers here? You plug 5 into the original equation, for x, and just see if it creates a new statement. Now, we've not talked about this a lot in detail, but the rules for checking your answer is always plug your answers back into the original equation. The original equation, right? If you plug it into a later equation after you made a mistake possibly, you'll still get a true statement even though, because that answer came from your mistake and the mistake is there. But the original problem shouldn't contain any errors. When you plug it in, you're left with 5 times 5 minus 6 equals 2 times 5 plus 9. Now, another rule here is that you don't cross the equal sign. You just evaluate both sides. You don't subtract 9 from both sides or add 6 to both sides. You just evaluate both sides and see if it's correct. Use the order of operations, and we get 19 equals 19, which is a true statement, which means our solution is good. Now, because you can check your solution to every equation, is there ever a reason to write down an incorrect answer on a test to an equation? If it doesn't check, it's not the answer. Okay, so just kind of keep that in mind. All right. More steps involved in this process, right? Now, we've not looked at a lot of equations in this course that had this many different steps in the process. 3 times x plus 4 equals 5 times x minus 6 plus 2 times x minus 1.
Should we try this?
Yeah, go ahead and work ahead of schedule if you want to. Everybody should be writing it down, though, not doodling in their notes. You got this written down there, Brady? Somebody please loan Brady Clayton a pencil. It's Brady Clayton of YouTube fame now.
He is kind of taping this, recording it.
Somebody have a pencil Brady can borrow?
Whoa.
Pen, crayon, colored pencil, chalk.
Can we
Thank you. All right. So, what do we have to do here? Our goal is to do what?
get the x by itself?
Our goal is to get x by itself, and I can't get x by itself at this point because all these x's are trapped inside these parentheses. So I can't get them together. I can't move anything around. I can't add or subtract things from both sides. I've got to get rid of these parentheses. Right? And we use the distributive property to get rid of parentheses, and that distributive property is going to look like that. Now we have to be careful with positives and negatives, making sure that every time we multiply we're obeying our integer rules for multiplication. So now I have 3x plus 12 equals 5x minus 30 plus 2x minus 2, which is still a pretty complicated mess, right?
Well, you just got to combine 5x and 2x.
So the next step of the process is to get the equation simplified. So we combine any like terms that we can combine. What can we combine on the right? The 5x and the 2x, and that would give us what? 7x. And we can also combine the negative 30 and the negative 2, and that gives us negative 32.
And subtract 3x.
So at this point, we could subtract 3x or we could subtract 7x. I'm not sure what the PowerPoint's going to do. It doesn't matter. You're going to get the same solution in the end. Okay? Don't be afraid of negative numbers. Don't try to avoid them. It's okay if you do. But this one did subtract 3x from both sides.
Okay, good.
If you subtracted 7x, that would be okay also.
I
Right?
know. It's just to see
All right. So then you get 12 equals 4x minus 32. Next step would be to
add 32.
add 32 to both sides.
We get 44.
We get 44, and then our final answer is x equals 11.
This is
Okay.
actually quite nice.
Y'all worked ahead, and how many of you got that correct working ahead? Good. Very good. Okay, so we haven't done a lot of equations that involve this many steps in the process, but in geometry you're going to be doing some of this, okay, because how many angles does a triangle have? 3. So you might be given a triangle that has an algebraic expression for each angle, All right, and what do you have to do with those three algebraic expressions? You want to find x. You need to set up an equation using the properties of a triangle. What's the property of a triangle that everybody knows? The three angles add up to 180. So you would just add those three expressions together and set them equal to 180. So those three expressions that you're starting with could look something like this. They could look like this, this, and this. So you're going to have to work equations like this in geometry. Okay? Solve for x and plug it back in to find the value of the variable. Okay? Good job on that one. Let's look at another one. You can check these also by just plugging 11 in, and you end up getting 45 equals 45.
Work again.
One more step in the process here, right? Now I'm distributing twice on each side. Where is the danger spot in this equation?
Everywhere.
Which negative sign, Robert? The one on the right side of the equal sign. We got to remember this, and it's one of those things, guys, that it wouldn't hurt when you write this equation down to draw some kind of attention to that negative sign, because when we're getting rid of that last parentheses, we're not distributing a 2, we're distributing a negative 2, and that's going to affect the signs of things.
Are we sure we're distributing -2 to x and -2?
Yes, we are sure. Yes.
Just that sometimes. Okay.
Okay. Now, when we multiply through and get this thing cleaned up, what are we going to have? Billy, what have you got it multiplied? You got the whole problem done? Okay, what's the next step going to look like? Do what? I'm right there. All right, what do you get when you distribute it? The whole equation, what do we get? When we distribute everything, what do we get? Naya, go ahead.
I got 3x minus 3 plus 2x plus 10 equals 5x plus 5 minus 2x plus 6.
That's exactly right. Okay. Minus 2x plus 6 there on the end. Now, but we still got quite a mess, right? What's our next step in the process here? Am I going to start adding and subtracting things from both sides here? No, not until I get it down to, your normal ax plus b equals ax plus b, the two linear expressions equal to each other. Now, here's a mistake that I see, and I haven't seen it from you guys in quite a while, but some people, to combine these two terms, will do this. Add 3 here and add 3 there. Why can't you do that?
Because it's not on a different side.
Because I've added 6 to one side of the equation. I have broken a rule, right? My center line here, whatever I do to one side of this equation, I have to do to the other. This is a really common mistake. Don't do it. Simplify both sides. Nothing's going to change signs because these two numbers are on the same side of the equal sign. What's negative 3 plus 10? 7. And 3x plus 2x is 5x. Over here, 5x minus 2x is 3x, and 5 plus 6 is 11. So our next step is looking like that. And this is a whole lot nicer, guys, than what we started with.
Then we get
But do you notice that all of our equations, just about all of them, reduce to something that looks like this? The steps are the same. Get rid of your grouping symbols, combine like terms, then we get the x by itself, and then we have a two-step equation to solve. We add or subtract, and then we multiply or divide. All right? So next step would be to do what? Subtract 3x. Remember, always let the variable go first. It avoids some complicated situations. When you subtract 3x from both sides, you get 2x plus 7 equals 11. When you subtract 7 from both sides, you get 2x equals 4. And when you divide both sides by 2, you get x equals 2. Right? Good? All right. Let's make things a little bit more challenging. Fractional equations. Since day one of solving equations, how have we approached equations like this? You take a common denominator, and what do you do with the common denominator? You multiply through the equation by the common denominator. So what's our common denominator, or a common denominator, going to be here? 12 will work. Any common denominator you choose will work. The least common denominator gives you smaller numbers to deal with. But if we take this equation and multiply it through by 12, then the skill of multiplying fractions comes into play here. We're going to cross cancel every time, and 12 times that. And you know what? Let me show you this. Some of you who are struggling with this might benefit from, instead of doing it this way, you might benefit from showing the multiplication on each term. So multiply this one by 12, multiply this one by 12, multiply this one by 12, multiply that one by 12. That allows you to kind of actually cross cancel. 3 goes into 12 4 times, and 4 times x is 4x, right? Plus 4 goes into 12 3 times, and 3 times 3 leaves us with 9. And then on the right side, 4 goes into 12 3 times, and that leaves me with 3x. And 2 goes into 12 6 times, and I got to remember that there's a minus sign there, so that's going to be minus 6. Okay? So that's where some of you are still messing up in this process. You're remembering to use a common denominator, but you're making a mistake when you multiply. So maybe it'll help you to show each step, maybe not. But just kind of, that's one other thing that you can work with as you're doing this. If we get to this and we get 4x plus 9 equals 3x minus 6, again, this is very familiar looking, isn't it? We have, mx plus b equals mx plus b, don't we? You know what this is? mx plus b. We've got two linear expressions. The slopes are different. 4 and 3 are different, so we know they're going to intersect. What kind of lines don't intersect? Parallel lines have the same slope. They're not going to intersect, right? So I know we're kind of mixing our topics here, but we're looking at mx plus b, so the properties of mx plus b apply. Does everybody see that 4x plus 9 is an mx plus b expression? What's the slope of 4x plus 9? 4. Y-intercept is 9. Slope on the right side is 3. The y-intercept is negative 6. Because the slopes are different, we know we're going to have a solution. All right? So when we subtract 3x, you guys are already finished with this problem. We get x equals negative 15. If you wanted to, you could plug negative 15 back into your original problem, check the answer, and make sure it works. It does. Okay? Do this one on your own. Okay? What's the first step?
Multiply by 15.
Multiply by 15, right? Take a common denominator and multiply through this equation by 15. And what does that give us?
5x plus 9 equals 30 minus 3x.
That's exactly right. Now, the key here, guys, is remembering to multiply the 15 by the 2. It's kind of easy to forget to do that because it doesn't have a fraction, and we're multiplying to get rid of fractions, so sometimes people forget to multiply by the 15, right? Did you get that?
Something wrong. I don't know why.
No, you didn't.
Bad.
You're good. Okay. And then you do what? What's the next step? Add 3x to both sides, and that will give us 8x plus 9 equals 30. Subtract 9 from both sides, and that gives us 8x equals 21.
Over 8.
And then you divide by 8, and you get x equals 21 over 8. Now some of you second guess yourselves when a fractional answer shows up. Don't do that. Most numbers are fractions, right? How many fractions are there between 0 and 1? there's an infinite number of fractions. So if we just pick a number at random, or if we just generate an equation at random, just using random numbers, we would almost never get an answer like x equals 5. We're almost always going to get answers like 21 over 8. Okay, so just kind of be mindful that just because a fractional value shows up doesn't mean you're there. All right, now we've got a couple special cases to deal with. Now this one looks a lot simpler, but there's something here that we have to remember. First step in this problem is to do what?
Distribute.
Distribute the 3, and when we distribute the 3, what do we get?
3x on both sides.
3x plus 12 equals 3x minus 18. Now, stop right there. I mentioned just a second ago, this is the stage where we have the mx plus b equals mx plus b on both sides, right? Mac is saying that this can't be true. Why can't it be true?
Because you're not equal.
Because these two linear expressions are not going to have an intersection point because they have the same slope. So these two lines would not intersect if you graphed them separately from one another. We have a slope of 3 on both sides. But what does that look like algebraically? So at this point, you could stop and write no solutions, right? But if we continued on and didn't notice that, what would the next step be? Subtract 3x from both sides, right? Some of you are trying to do something different. Remember, the variable always goes first. All right, so if we subtract 3x from both sides, what happens to our x terms? They're gone. No más x's. Spanish for no more x's. No más x's. And we're left with a statement that is not true. If your variable disappears and you're left with a statement that is not true, that tells us that this equation has no solutions. Okay? All right? We could have seen that earlier just by examining slopes. All right? Now this one, we're kind of getting short on time. Just pay attention.
Don't write it.
No, you don't write this one. What's going to happen here when we distribute on both sides? What are we left with? 6x plus 12 equals 6x plus 12. Now, these two lines are what?
All real numbers.
They're exactly the same lines. If we were looking at this as a system of equations, we would say it was consistent and dependent, meaning it has infinitely many solutions. And what that means in this case is anything we put into this equation is going to result in a true statement, and our solution is all real numbers because those two linear expressions are identical to each other. 12 equals 12 is what you get when you subtract 6x from both sides, and you go from there. Now here's the tricky part. Okay? The tricky part is this equation. What do you get when you add or when you distribute here? 5x plus 10 equals 2x plus 10.
X equals 0.
Yeah, he's right. And the reason he's right is, but this is what some of you will do in the context of your special cases. Right? X equals 0, y equals 10. The y-intercepts are the same, which means these two lines intersect at the y-intercept, right? Where is the y-intercept on a line? It's where x equals 0. Okay? Right? These two lines, and let's, since we're talking about this mx plus b thing, these two lines have different slopes, which tells me that we do have a solution, right? Different slopes will intersect. But they show us the point of intersection. The point of intersection is the y-intercept. By definition, where is the y-intercept? Where x equals 0. So the solution here is x equals 0 if we think about this from a graphical standpoint. All right? But if you continued on, you get 3x plus 10 equals 10. Subtract 10 from both sides. 0 shows up, and a lot of people at this time would say this is all real numbers or it's no solutions because there's a 0 there. But there's never a special case as long as we have a variable left. If we have a variable left, we're going to continue solving it We're not going to hate on 0. We're going to divide both sides by 3, and we're going to get x equals 0. All right? It's a good solution. It's an easy number to work with. All right? That's it. That's not your homework. I'm going to give you your homework in just a second. I want you guys to enjoy a great long weekend, Easter weekend. He is risen. Make wise choices.